Despite not going as hoped, it has still marked an era. The idea of a private company dedicated to space exploration, proposed in the early 2000s, was mostly ridiculed and considered unattainable. But now, reality is quite different. We are talking about an independent organization that, against all expectations, has broken every record, rendered previous satellite technology models obsolete, conceived the most powerful rockets ever seen, and now is on track to create the first vehicle capable of transporting humans to Mars and bringing them back. Clearly, we are talking about SpaceX. Birth of SpaceX. Today, SpaceX is a shining beacon in the global aerospace industry, known for creating the most powerful and efficient rockets ever conceived by humans. Those in the industry now associate its name with excellence. Thanks to SpaceX, the costs associated with launching objects into orbit have drastically reduced, about 10 times less than in the past, a revolutionary progress enabling previously impossible projects. However, when Elon Musk decided to found this company, few people would have bet on its success. The idea of a private enterprise dedicated to launching missions to Mars seemed not only unrealizable but downright insane. It appeared as a whim of the young Musk, who had quickly accumulated a huge amount of money. Even his former PayPal colleagues turned their backs on him in the early years. But let's go back to the beginning. In 1997, Elon Musk earned 2 degrees from the University of Pennsylvania, one in physics and the other in economics, the latter from the renowned Wharton School of Economics. Meanwhile, he and his brother started their first entrepreneurial project called Zip2. Not satisfied, he embarked on a physics PhD in 1997, which he abandoned almost immediately to fully dedicate himself to entrepreneurship. However, his passion for physics did not wane. In the meantime, he developed and sold Zip2, pocketing around $22 million, according to rough estimates. He would later participate in the founding of PayPal, providing him with the launching platform for the entrepreneurial adventures we know today. From the sale of PayPal, he earned $175 million, a sum so significant that he seemingly didn't know what to do with it. But Musk's choices were decisive. In the following years, the funds obtained from PayPal would be invested in 3 initiatives: SolarCity, Tesla, and, before these, SpaceX. After the experience with PayPal, his main aspiration was to return to his old passion, physics, particularly astrophysics. In 2001, he joined the Mars Society, a non-profit organization committed to supporting research and exploration projects on Mars to push for government funding. However, after acquiring funds from PayPal, he decided to go forward independently. His initial project did not involve creating a company for the development and production of rockets. He simply wanted to reach Mars to conduct research. His initial idea was simple. He wanted to conduct an experiment, send an autonomous greenhouse to Mars to study how plants react to the weaker gravity and magnetic field of the red planet, both considerably weaker than those on Earth. He started with this first step, with the goal of demonstrating that even the colonization of Mars could be a possibility. At this point, the major challenge was to obtain the rockets needed to transport the automated greenhouse to Mars. Musk decided to look for them in Moscow, Russia. In 2002, only in the former Soviet Union nations were there entities from which a private individual could buy and launch rockets. Musk contacted Cosmotras, an organization formed in '97 in collaboration between the governments of Russia, Ukraine, and Kazakhstan. Although it is currently solely under Russian management, Musk flew to Moscow to meet with Cosmotras delegates and negotiate a contract. He wanted to buy 3 of the company's rockets, the Dnepr, former Soviet intercontinental ballistic missiles capable of sending objects into orbit. However, the negotiations did not go as expected. For a launch, the market price was tens of millions of dollars, ranging from $20 to $50 million, just to send a few satellites. The exact cost varied based on specific requirements and contracts. Despite Musk hoping for a discount, as he did not aim to send satellites for commercial use like typical Cosmotras clients, but rather to undertake scientific research, Cosmotras executives not only did not support his project, and thus were unwilling to give him a discount, but also found Musk's proposal absolutely senseless and ridiculous. As some of Musk's assistants would later recount, the negotiation table was full of vodka and other alcoholic beverages. Cosmotras executives drank incessantly and mainly directed sarcastic remarks or questions at the entrepreneur. They often ignored what he said, talking among themselves, which might seem rude, but at first, Musk attributed this behavior to local cultural customs. He then presents his project and offers less than $8 million to buy a rocket, even trying to request two for the same amount. When they hear his offer, Cosmotras executives openly show their disdain. They'd practically mock him, ridicule him for not having enough money, and scoff at him for not checking the price of a rocket. It is said that one of the Cosmotras representatives, after the meeting, even spat on Musk's shoes after another failed negotiation attempt. In the end, the response from the Russian company is clear. If he wants 3 rockets as he requests, he must pay at least $20 million each, excluding fuel. And they are one of the few companies he can turn to, so either he accepts their offer or gets nothing. In the end, the deal falls through, with Musk returning not only defeated but humiliated. He is forced to abandon his Mars project. But perhaps it is not the end. Musk stops to reflect, reviews the documents, analyzes all the costs, and realizes something. It is not necessary to spend so much to build a rocket. The primary materials to build it, like copper and aluminum, represent only 3% of the total price. Much of the cost, he realizes, comes from technological limitations and technical problems, difficulties that, according to him, could be overcome. It's not just a matter of technical limitations. The aerospace industry, like several other heavy sectors, has a complex structure. Multiple entities participate in rocket production, and each applies its profit percentage to the price, that increment that allows them to make a profit. With each contract and subcontract to produce each individual component, costs skyrocket. So he realizes that the aerospace sector has exorbitant costs and is not efficient at all. The technologies used could be significantly improved, and the work is divided among an excess of companies. All this makes him understand that production costs can be significantly reduced. He can minimize subcontracting, plan, and produce components autonomously, and internally address technical issues to reduce costs. In this way, he could lower selling prices, surprising the competition, especially Cosmotras. He lights up, realizing that there is an untapped market segment since Cosmotras is one of the few companies conducting satellite launches for private individuals. He understands the enormous potential held by the satellite sector. He concludes that not only should he not give up the dream of Mars, but he can also build his own rockets and generate profits. And it is from this reasoning that the idea of SpaceX is born, from a botany experiment never conducted on Mars in Elon Musk's shoe spit. After returning to the United States, the entrepreneur wastes no time, withdraws $100 million from his bank account, and founds SpaceX. In the following years, using proceeds from PayPal, he also invests in 2 other companies, SolarCity and Tesla. $100 million at that time represented almost 60% of the $175 million earned through PayPal. From the beginning, the goal of the new company is to produce the most efficient and economical rockets ever made. But achieving this goal is by no means simple. There is a world of difference between saying and doing. For this reason, no one takes him seriously at first. At the beginning, in addition to an additional investment of about $12 million, most funds come directly from Elon Musk. No other investors are seen. Almost no one seems willing to bet on SpaceX. Consequently, the company's first years are a constant struggle against time. Without the arrival of new funding and without any profit, they must necessarily achieve tangible results before the funds run out. Otherwise, the company will have to close. The first step in this situation is to find the right people, but it is not an easy task. The best and most experienced engineers in the aerospace field are already employed at large companies, so he needs to find someone competent who is not already involved in the industry. The person he finds is Thomas Muller. Muller is an engineer working for TRW, a company that produces components for engines, mainly for cars, but also for rockets. Musk selects him not so much for his work at TRW, but because Mueller, in addition to being a capable engineer, is also a great enthusiast of rockets. As a child, Mueller made flying models, and even as an adult, he dedicated his free time to building amateur rockets as a member of the Reaction Research Society, an organization where members collaborate to conduct independent experiments. In 2002, while founding SpaceX, Musk was impressed by Mueller, an engineer who had succeeded in building and flying the largest liquid-fueled rocket ever designed by a private individual. Musk recognized in Mueller a remarkable talent for optimizing components and being able to do a lot with limited resources, essential qualities for his project. Thus, Musk decides to appoint him as CTO, the technical head of his newly born company. Mueller has always dreamed of designing rockets. However, growing up in a not-so-affluent family, he couldn't afford to attend high-quality colleges. During his studies, he worked to pay university fees, and before the advent of SpaceX, job opportunities in the aerospace industry were few. Despite his resume, Mueller struggled to compete with engineers graduated from the world's top universities. Thanks to Musk, he finally had the chance to realize his dream, an opportunity he knew was very rare. Musk chose a determined person ready to dedicate himself entirely to work, which he perceived as a personal challenge. Without wasting time, in 2003, Mueller's team presents SpaceX's first significant technology, the Merlin engine, a crucial step toward internalizing the production process. A truly unusual fact was that the engine was entirely built within SpaceX. In fact, to minimize costs, SpaceX tries to keep most of the production internal. Any operation that takes too much time or is too costly to outsource is implemented in-house. SpaceX even opened its own welding laboratory, also useful for autonomously producing the alloys needed for materials. Although they seem like an apparent additional cost, this allows the company to speed up the process, avoiding the high costs of suppliers accustomed to inflating prices for government agency sales. This is SpaceX's first significant innovation in the industry. The vertical integration of the production of all parts necessary for rockets is a process innovation that allows SpaceX to save millions and millions of dollars in the long term. They produced their first engine in record time, and in 2004, they demonstrate that their technology is effective. The first test of the Merlin engine is a success. After creating the engine, they need to design the rocket on which to mount it, a process that requires funding. Despite the initial success, SpaceX is still not taken seriously, and investments are still lacking. Most people still consider it a crazy idea, but despite this, the first projects for the creation of the Falcon 1, the company's first complete rocket, are underway. The estimated cost is between $7 and $9 million. The strength of the project is that it manages to keep estimated shipping costs competitive with those of the best competitors. Comparisons are based on the cost per kilogram of payload delivered to orbit. The Falcon 1 had a cost of about $12,500 per kilogram, the same as Cosmotras Nepper in 2002, which cost between $12,500 and $10,000 per kilogram, depending on the type of launch. The Lockheed Martin and Boeing Delta Heavy, created in collaboration for NASA, also had a similar cost. However, Falcon 1 is a very small rocket and has the ability to carry just over a ton into orbit. It is not ideal for transporting large payloads into orbit. Despite this, SpaceX wants to present the project to NASA, the United States Space Agency, which was meanwhile looking for ways to cut the costs of space transportation. For example, the shuttle they used in those years was among the most expensive means ever seen to carry objects into space. Although very reliable, it cost over $50,000 per kilogram delivered to orbit. Even though the cargo costs of the Falcon 1 were drastically lower, NASA was initially not interested in the Falcon 1 project. They didn't even want to consider it. NASA had launched a tender to develop a new system to resupply the International Space Station, but effectively only Lockheed and Boeing were allowed to participate with the Delta Heavy. However, in 2005, SpaceX turned to antitrust to force NASA to consider their project, suing them. Thus, NASA engineers were forced to consider SpaceX's work, and indeed, The technical goals, although very ambitious, were realistic and promising. It was not certain that the technologies devised by SpaceX would work, but they could work. And if they did work, it would be a breakthrough. At this point, in 2006, NASA allocates $278 million to the company to proceed with the development of their rocket and a new capsule. This allowed them to create the first concrete prototypes of the Falcon. As an aerospace engineer would state, you can never be sure of the functioning of a flying object until you actually make it fly. However, the Falcon 1 did not fly, at least not initially. The first attempt in 2006 is a failure. The second attempt in 2007 was also unsuccessful. With the third attempt, they were convinced they had identified the problem from the previous two. It was time to put it to the test. It had to work, or they would run out of funds. As Musk often recounts, the company would likely have gone bankrupt if the third attempt had not gone according to plan. We then come to August 2008, the crucial moment. Musk and Mueller are about to see their project reach orbit for the first time. They invested a significant portion of their funds to improve and produce the rocket, but it explodes again. This time, the accident was catastrophic. Without a successful test, NASA would not provide further funding. They were again convinced they were very close to the desired result, claiming to have understood the mistake, and they were almost sure a fourth attempt would succeed. Still, the situation was critical. They couldn't secure additional funding from anywhere else. The 2008 crisis was about to break out, and investor confidence was at an all-time low. Musk could no longer financially support the company, especially since he risked bankruptcy with Tesla as well. Practically, his entire wealth was tied up in his ventures. It seemed like the end. They had to act quickly, or NASA would choose another candidate. So they organized one last desperate test in a very short time. The work pace was exhausting. In 2008, SpaceX had just over 500 employees, seemingly a high number, but relatively small considering the challenge of developing and building a rocket in just 1 month. However, at the beginning of September 2008, a new Falcon 1 is ready for launch, built in record time. The countdown begins, pause with countdown background and engine noise. Finally, it takes off, following the planned schedule. On the fourth attempt, the experiment is successful, and NASA decides to invest seriously in SpaceX, awarding them a $1.6 billion contract for the International Space Station resupply program. SpaceX can finally claim to be open for business. The fundamental technologies have proven to work, and now the primary concern is to develop an even more powerful rocket. Technologically, the Falcon 1 is impressive, but it's not enough. To surpass Lockheed and Boeing's Delta Heavy, they need to take a leap forward. But at least, after the success of 2008, money for investment is no longer lacking. In addition to the NASA contract, SpaceX receives a significant influx of capital. Between 2009 and 2010, SpaceX attracts over $150 million. And since it's not a publicly traded company, investors have to deal directly with Elon Musk and his team. With the new funds, SpaceX engineers work on a new project, developing a rocket similar to the Falcon 1 but larger. Finally, in 2010, the Falcon 9 is revealed. The name 9 reflects the fact that this rocket is equipped with 9 Merlin engines instead of just one. The new rocket has the capacity to carry up to 17.5 tons, significantly more than the Falcon 1's 1-ton capacity. This version stands out from the Delta Heavy, with a cost ranging between $1,500 and $3,000 per kilogram transferred to orbit, much less than its rival's $12,000. Moreover, this time, the first attempt is a success. After a few months, the new Dragon capsule, designed to transport both cargo and human crews into orbit under the NASA contract, is also tested. This test also goes well. So in 2011, SpaceX secures another NASA contract. This time, it's not about research. It's effectively an operational contract. The task is to transport supplies to the International Space Station, with an initial agreement for 12 launches, later expanded to 20. If all contract objectives are met, NASA will provide up to $3 billion. In May 2012, the first Falcon 9 launches the Dragon into orbit to dock with the space station, carrying supplies for the astronauts. This is the first time a vehicle from a private company reaches the International Space Station. SpaceX has already exceeded all expectations, accomplishing what aerospace companies normally do, but faster and at much lower costs. However, this is not enough for Musk, who is still determined to take humanity to Mars. He wants to develop spacecraft and rockets capable not only of launching objects into orbit or beyond, but also of landing and taking off again, just like a real spaceship. A truly impressive milestone. Typically, building a rocket involves expenses that easily reach millions of dollars, and historically, they were considered disposable, true single-use rockets. To cut down these huge costs, SpaceX dedicated itself to developing a system that could allow rocket re-landing, making them reusable over time. Initially, the company tried to recover a Falcon 1 using a parachute, although unsuccessfully. Starting in September 2011, the idea of reigniting the engines during the descent phase to the ground emerged, eventually considered the most advanced solution possible. Easier said than done. In 2012, Elon Musk emphasized the importance of this goal for the future conquest of Mars, otherwise prohibitively expensive. Various tests were conducted using both the Grasshopper vehicle to assess maneuvering capabilities and rockets designed to withstand re-entry into the atmosphere. In September 2013, they managed to reignite 3 engines during the return of a Falcon 9 that had previously launched satellites into orbit. Despite the rocket not landing, it re-entered the atmosphere without damage, marking a significant milestone. Between 2014 and 2015, there were additional attempts, which, despite failures, allowed them to collect valuable data. In the end, December 2015 arrives. After years of preparation, the Falcon 9 meets expectations and lands successfully. It's another significant milestone for the company. Despite the celebrations, the transition from landing to reusing the same rocket was not straightforward. The rockets in the years following 2015 suffered various damages for re-entry, resulting from engine overheating, impact with the ground, or re-entry into the atmosphere. We will have to wait until 2017 to see the first true reusable rockets. Once this goal is achieved, one cannot remain idle. The rocket works, flies, and even completes its journey. The priority now, as always, is to understand how to increase its size to allow it to carry even more payload, from Falcon Heavy to Starlink. Here begins the Falcon Heavy project, a model much more powerful than the Falcon 9, capable of carrying over 60 tons into orbit, compared to Falcon 9's approximately 25 tons. However, to reach its most performant version, it's crucial not to save fuel for landing. The cost to launch objects into orbit is thus reduced to a range between $800 and $1,600 per kilogram, decidedly less than half compared to the cheaper competitors. The Falcon Heavy project is straightforward. How can one create a more powerful rocket than the Falcon 9? Easy. 3 Falcon 9s are joined. A nose is added to make it more aerodynamic, and voila! There you have the Falcon Heavy. Of course, it's not as simple as it sounds, but the idea is not far from reality. The base of the Falcon Heavy is, in fact, built from the carriers of 3 Falcon 9s, which can be used even if previously utilized. Everything works, at least in theory. For the first test of the Falcon Heavy, SpaceX prepares a unique show, worthy of an event considered a milestone in the space age. The chosen location is Launch Pad 39A at the Kennedy Space Center, where the rockets that took humans to the moon were launched. And once again, the show does not disappoint. The Falcon Heavy takes off without any issues, surpassing every test phase successfully. It reaches hypersonic speed. The side boosters detach from the central section and begin their controlled descent. Musk reveals to the world the payload he wanted to show everyone. His Tesla Roadster with a mannequin at the wheel and David Bowie's music in the background. A unique advertising feat. Before one can fully comprehend the scene, the 2 side boosters perform a simultaneous landing, only a few tens of meters apart. The world witnesses something extraordinary, an event that will mark the history books. However, not everything goes according to plan, as the central rocket fails to land as predicted. But that matters little. What customers are really interested in is launching satellites and cargo into space. Therefore, the Falcon Heavy is entirely ready for commercial flights, and indeed, the second Falcon Heavy flight was carried out on behalf of Arabsat, the world's leading satellite telecommunications operator. The launch and orbit mission went well, and this time, all 3 rockets landed successfully. The idea of reusable rockets has been hugely successful, and SpaceX has certainly set another new record. However, it's not the only company working on this innovation. There are other private space companies in competition, some of which were founded earlier, such as Jeff Bezos's Blue Origin, launched in 2000. It's challenging to compare them since, in 2023, Blue Origin has only the New Shepard to focus on, also dedicating itself to other projects. The New Shepard is a vehicle that can carry a maximum of 6 people for a suborbital tourist trip. An attractive journey, but without reaching orbit. Well, obviously, they try to land the carrier safely to allow tourists to return home safe and sound. However, this doesn't mean that other companies are out of the competition. The technological race continues to be intense, not least because other companies are developing new spacecraft. For example, we can consider NASA, which has commissioned the design of lunar capsules for the Artemis 3 mission, with the goal of returning humans to the Moon by 2025. For this purpose, the agency has made agreements with both SpaceX and Blue Origin, allocating a significantly larger share in favor of Jeff Bezos's enterprise. According to NASA, both companies propose interesting ideas. However, SpaceX is far ahead in terms of technologies developed in 2023, as highlighted by the current state of the satellite launch market, where SpaceX overwhelmingly dominates after 2020. In 2022, SpaceX also secured a military contract with the United States worth about $100 million to create systems capable of transporting military supplies, provisions, and medical supplies to conflict zones. Imagine a rocket landing in a war zone to deliver supplies. Also, in 2022, SpaceX was the company that received the highest investment from NASA, surpassing even Boeing and Lockheed Martin. But SpaceX is not satisfied with just leading the field of space launch vehicles. In fact, the company has decided to venture into a massive project to enter the satellite telecommunications sector, known as SATCOM. The ESA estimates that this type of market has a value of approximately 100 billion euros per year for now. The project in question is Starlink. You've probably heard of it. Launched in 2019, Starlink is a project that involves placing tens of thousands of satellites in orbit, forming a low-Earth orbit constellation. These satellites can provide internet access anywhere in the world, provided the necessary devices are purchased for use. The development of the entire network will cost the company between $20 and $30 billion. One distinctive feature of this network is its high connection speed, made possible by the low orbit of the satellites. However, for the network to be fully operational, it should reach a number of at least 12,000 satellites, with over 4,000 expected by 2023. If you recently looked up at the night sky, you've probably seen a few of them streaking by. The project's goal is to launch about 42,000 satellites into orbit. Currently, Starlink satellites represent about half of all satellites launched into orbit by humans, occupying a significant portion of the orbital space. Although not fully complete, Starlink service is already available in some authorized countries, although not exactly accessible to everyone. The equipment needed for the signal costs about $500, with a service cost of $99 per month. In the future, it is expected that the price may drop, thanks to an increase in the number of customers and technological progress. However, even now, it is the most cost-effective solution for fast internet access in remote and isolated areas of the world. The U.S. military has also shown great interest in using Starlink services in conflict areas in the coming years. Elon Musk predicts that in the next few years, Starlink will become the main source of income for SpaceX, while still maintaining the primary goal of reaching Mars. And in light of the tests performed with the Falcon Heavy, this aspiration no longer seems so inconceivable. Starship, Mars getting closer. In 2016, SpaceX begins discussing the creation of an exceptionally powerful rocket, the most powerful rocket ever. But it's only in 2019 that it will be called by its current name, Starship, literally a spacecraft. The project envisions Starship to have a height of 121 meters and the ability to carry up to 250 tons of cargo into orbit. The new model should also achieve unprecedented levels of efficiency. Looking at payload costs, Starship is expected to reduce the price of space shipments to less than $200 per kilogram transported to orbit. This is largely due to its full reusability, far surpassing the Falcon 9 and making long-term crewed missions to the Moon or even other planets more realistic. For its Starship, SpaceX has developed a new type of engine called Raptor, replacing the Merlin conceived by Muller. These new engines do not use kerosene as fuel, as is the case with most rockets, but use methane, which is cheaper and can generate greater thrust. Musk also emphasizes that methane could be synthesized on Mars, making the return journey much more practical without the need to bring large amounts of fuel from Earth. The Raptor could be the most complex engine ever created in history. Such an engine has no precedent. It would represent a groundbreaking change in the field of space travel. Of course, despite everything, it's not guaranteed that Elon Musk will be able to establish a colony on Mars. What is your opinion? Share your thoughts with us in the comments, and remember to give the video a thumbs up. See you next time!